Hi everybody, welcome to another video in Precalculus, section 9.4, the hyperbola. So, by definition, the hyperbola is the collection of all the points in the plane where the difference of the distance between two fixed points, distance from two fixed points, the foci is constant. So what we have is two foci, so focus here and the focus there. And a hyperbola is the set of all the points where the difference from a point, let's say if we have a point on the hyperbola, so distance from that point to a focus and the distance from that point to the other focus, the difference of these two distances is constant. So let's say this point is let's say a point A belongs to the hyperbola, so we say the distance, we know that the distance here to the second focus is longer, and then we subtract the distance from A to the closer focus, and that has to be equal to a constant. Of course, we might have another point, doesn't matter what the point is on the hyperbola, they will have these properties. Of course, if the point is on this side, I mean on the other branch of the hyperbola, maybe this one, then it is closer to focus 2 than focus 1, but the difference between them is still the same. So to guarantee that is true, we can put absolute values here. So the distance from the point to the further focus, subtract the distance from that point to the closer focus, is going to be constant. So that's what we have. Right. So that's the definition. But characteristic of a hyperbola, we need to know those characteristics so we can link them between the graph and the equation. Right. So let's review. For parabola, we have a vertex and one focus. Focus is on one side, the directrix on the other side, and the parabola will go around the focus, go through the vertex, and the distance from a point to the focus is the same as the distance from that point to the directrix. So that is the parabola. Ellipse. Ellipse, the characteristic is there is a center, two foci, and two vertices, on the which on the line, and that line is called the major axis. And we will have distance to the other side perpendicular to the major axis is called the minor axis. And that distance is b away from the center. And the ellipse will be inside. Will be inside of that box. Right. The equation is x minus h square divided by something square. In this case, this one won't be horizontal ellipse. So we just talk about the characteristic. So the characteristic of a hyperbola is this. We still have the center. We still have two vertices and we'll still have two foci. The difference is all of those points now lie on the transverse axis. Will contain a center, two vertices, and two foci. The difference is the foci will be on the outside with respect to the center compared to the vertices, as opposed to for the ellipse, the two foci will be in between the center and vertices. Right, so kind of backward. We do not have the minor axis, but actually the way to graph it, well, and look at this. If this happened to be a plus, then we go A unit left and right, and then B unit, let's say this is B unit up and down. So if that is the case, we might have the box like this. But the difference is in the ellipses. What we have instead of the ellipse, we will have the asymptotes. So we still have the box just like we have for the ellipse. So by the way, the ellipse will fit inside this box. But instead, the characteristic of the ellipse or the characteristic of the hyperbola is not going to be the minor axis. It is going something else. And it's not important. But we still have the box. And on that box, we will have the diagonal as the asymptotes. And once we have the asymptotes, it will be very easy to draw the hyperbola with respect to that. So if this is the plus, we will have the box, draw the box with the diagonal, and then we have the ellipse. So it's easy to graph it that way. Right, same thing here. We can draw the box and the diagonal. By the way, the box, the distance from that is also B. It's not the minor axis, but we just call that B. So we still have the box. Instead of the ellipse inside, we draw the diagonal, and those are the asymptotes. The ellipse will be that way. I mean, touching the vertices and approaching to the asymptotes. Right, now, just need to notice that if we have, this is the horizontal, the transverse axis is horizontal. So this is horizontal. Horizontal hyperbola, we start with the x, subtract the y. If it is vertical, we start with sorry, I copy and paste it. Forgot to. If it is vertical, so we have y square instead of. Right. If we have y square, subtract x square, that's a vertical. X square minus y square is going to be horizontal. And then, now we go back to what we have earlier. The distance, this is what we have earlier. The distance from the center to the focus is going to be C. The distance from the center to a vertex is A. We still have that. But in this case, the C is going to be bigger than A, meaning A squared plus B squared is equal to C squared. C is the biggest distance out of those A, B, C. So we have this relation. Right. Still the same. C is the distance from the focus to the center, and A is the distance from the center to the vertex. And in this case, C is bigger than A. We can find B to draw the box and the ellipse. Right. So that's what we have. Right. And then the equation, the ellipse, like I said, it would be best if you don't have to memorize any formulas. Now once we have the box, it is easy to say that rise over run. So this is up B unit and A unit to the right. Yeah. So actually this one is in this case, because we have x squared go first. So this is horizontal, and we have the horizontal hyperbola here. And since it's go B unit up and A unit to the right, it's always y equal to the slope mx, and m is the slope, it's rise over run. So the equation of the asymptote is this. Of course, this could be plus or minus. So plus or minus. Right. Right. Summarize all of this. We have the center, two vertices, two foci, all of them aligned on the transverse axis. To get B, we get from Pythagorean theorem, where A, the distance from the center to the focus, is the biggest. And then we can find B, draw the box, draw the diagonal, and then we have the hyperbola. Right. So let's look at the example here. Find equation of hyperbola with the center at the origin. So the center zero, zero. One focus is 4 and 0, and one vertex is -3 and 4. Right. So we have the centers here. One focus, 0 and 4. 0 and 4. I mean 4 and 0, sorry. 4 and 0. They are the focus, and of course there will be the other focus on the opposite side from the center. And that distance is 4. So we say the distance from the center to a focus is going to be C, and that is equal to 4. And then we have one vertex is at -3 and 0. One vertex here. Of course, there will be another vertex here. And the distance from the vertex to the center is going to be A, and in this case, -3 to 0 is going to be 3. So we have A, we have C. Now, Pythagorean theorem, we have, in this case, from center to the focus is the longest distance, so A is the biggest one. I'm sorry, C is the biggest one. A squared plus B squared equal to C squared. And then we can solve for B. B squared is equal to C squared minus A squared. 4 squared minus 3 squared. 4 squared is 16 minus 9 is 7. So B squared is equal to 7, or B equals square root of 7. Square root of 7 is about 2.65. Right. If we want to graph, we need the box, and the box A, 3 left, 3 to the right, and we have 2.65 go up and down the same amount. So 2.65, -2.65, and we have a box. Sorry. The box will go to the vertex. Always the box is A and B. and then we will have the diagonal. And then in this center vertices, four sides, everything aligned horizontally. So this is going to be a horizontal parabola, hyperbola. So it's going to be from the vertex approaching to the asymptotes. So that's what we have. Right, so that is the graph in terms of equation. This one is horizontal, so we're going to start with x squared minus y squared equal to 1. Now the rest is easy. Since this box we go left and right 3 units, so put 3 square under the x, and up and down square root of 7 or square root of 7 square, and that's what we have. Of course, or x squared over 9 minus y squared over 7 equal to 1. Right. Now if we want the equation of asymptotes, it's going to be y equal to plus or minus up square root of 7 rise over run 3x. So this is asymptote. Is that equation? All right. Of course, we can write the coordinate of four sides and the vertices and the center, but that's what we have. Next, analyze the graph x squared over 25 y squared minus y squared over 9 equal to 1. So the right side is equal to 1, which is good. Now, we have 25 below the x. So that means we're going to go left and right 5 units on the x. But let's just get the graph first. So we go left and right 5 units. And we start with x. And so those are the vertices. X squared and y squared. If it is x minus 8 or y minus k, then we have the center. In this case, the center would be at 0, 0. 5 on the left and 5 on the right. Those are the vertices. 9 below the y, so we have plus or minus 3. So 3 up, 3 down on the y. Okay. So let's draw the box first. And then the diagonal. We start with x, so this is going to be horizontal, so it's open sideways from the vertex approaching to the asymptotes. Right, so look like that, the hyperbola. Right, so other characteristic that we need to know. By the way, the distance here, we know 5, so 5 here, that is the distance from the center to a vertex, and that is A, it's going to be 5. And 3 is B, the other distance. and we have A, we have B, we have C. C will be the biggest one, which is the distance from the center to a focus is going to be C. So we have A square plus B square equal to C square, and so we just put those in 5 square, 3 square equal to C square. So C square is equal to 25 and 9, that's 34. So C is square root of 34. Which is about 5.8. So meaning that the two foci will be about 5.8 from the center, but we have two foci on the outside. So those are the foci. Yeah, about 5.8 away from it. So if we want to write the foci will be plus or minus square root of 34, comma 0. And the vertices plus or minus 5, 0. And the equation of asymptotes is going to be y equal to rise 3, run 5. Right? So, just like the ellipse will be inside the box and the two foci will be inside the box. The hyperbola will be outside of the box, two foci outside the box. Right. Next, analyze and graph this equation. So first, the equation of the hyperbola, we have 1 on the right side, so we'll divide by 9 on both sides. Right. So we have y squared over 1 minus x squared over 3 squared equal to 1. Right. Now if we draw the box, 1 unit will be, so yeah, so we have plus or minus 1 under the y should go up and down 1 unit. And we have 3, so plus or minus 3, and that is going to be B, but that's negative 3 and 3. Right, and then the diagonal. Those are the characteristic. Of the hyperbola. Right, now we have the y square subtract the x square, so this is going to be a vertical, because this is going to be the vertical ellipse. This will be a vertex. By the way, center in this case still 0, 0. So center, if we have y minus something, x minus something, that would be something else. But in this case, center will be 0, 0. Right. The distance from the center to a vertex is equal to a, and this is equal to 1. And the other distance is 3, so b is going to be equal to 3. And then we just need to find c. A squared plus b squared equal to c squared, because c is the biggest distance. So to solve for c, c squared equal to a squared plus b square, so 10. So c is square root of 10, which is about 3.1 something. 3.16. Right. So the foci will be the distance from the center to a focus. It's going to be c, and that is about 3.16. So 3.16. So the focus is here and here. And the graph of the hyperbola, will go through the vertex around the focus and approaching to the asymptotes. So it's open up and down like that. Right? So when we have the equation, we draw the box and then we draw the diagonals and then determine if it's going to be vertical or horizontal hyperbola. This one is vertical because we start with y square. If we start with x squared, it's going to be horizontal. If it is horizontal, that will be the transverse axis and the center in the middle, 2 foci on the outside and 2 vertices in the inside. Right. Now, what next is we pretty much do the same thing, but this time we have the center is no longer 0, 0, but then still we do the same thing from the center to the focus, the center to the vertex. Right. Now we have this example. Of course, the equation here, if we want to, we can just look at that. Like I said, I do the problem not relying on knowing the formula. Just know the characteristic of hyperbola. Center in the middle, 2 vertices, and then 2 foci on the outside. The distance from the center to the foci will be the bigger distance out of all of those little distance. Right. So find the equation of hyperbola which center is -1 and 2. So x equal to -1, y equal to 2. That is the center. One focus is as -4 and 2. Alright, so focus at x equal to -4, y equal to 2. This is one focus. And of course, we know that if one focus is this, there will be one on the opposite side. So this is 1, 2, 3. So 1, 2, 3. There should be another focus on the other side. And one vertex is -3 and 2. The vertex -3 and 2. So if the vertex here, there will be another vertex on the opposite side. And everything aligned, so we will have the transverse axis horizontal. Right, next, let's write out the distance from the center to the focus, to a focus, is going to be c, and from -1 and 2 to -4 and 2, those 1, 2, and 3 units. The distance from the center to a vertex, that is a, and from -1 and 2 and -3 and 2, that distance is 2. So in this case we have the hyperbola, of course, and then we have a and c. We should be able to find b. So, and out of all of those a, b, c, c is going to be the biggest one. So a squared plus b squared equal to c squared. So b squared is equal to c squared minus a squared, 3 squared minus 2 squared. 9 minus 4 is 5. So b equal to square root of 5, which is about 2.24. Right, so we have A, B, and C. By the way, B would be the distance, that is the perpendicular to the transverse axis, 2.24, 2.24 up and 2.24 down. So we can have a box we can draw the diagonal. Keep doing that. The box is up to the vertex, not to the focus, sorry. Right. So that is the box. I'll draw the diagonal. And since the transverse axis is horizontal, the hyperbola also horizontal from the vertex approaching to the asymptotes. So that's simple enough, right? Now in terms of equation, this one is horizontal because everything aligns horizontally. So we start with x first. And then y. This time we do have the center of -1 and 2. -1 go with x and 2 go with y. And now the horizontal distance we go left and right 2 units. And go up and down, so that below the y square root of 5 square. So we have x plus 1 square over 4 minus y minus 2 square over 5 equal to 1. Right. Now if we want the equation of asymptotes, instead of y equal to mx, we do have the center is different, so y minus 2 equal to the slope go up square root of 5 and then go to the right 2 units, and then x minus -1. Yeah, so if we have the center, just consider that in the equation with asymptotes as well. Right, like I said, don't need to memorize anything. Just know the characteristic of the parabola. Right, so we have the asymptote. If we want to write the coordinates, let's say if we want the coordinate of the vertices, we know the center is as -1 and 2, so we start with -1 and 2. But this one, it is horizontally, and the vertices we go left and right 2 units, so we just have plus or minus 2 and 2. So that gives us -3 and 2 and 1 and 2. So we have those are the coordinates of vertices. If we want the foci, we start from the center, but this time the distance from the center to the foci is 3, so we just have plus or minus 3, and we have the foci, so that gives us -4 and 2 and 2 and 2. Right, so yeah, as always, try to link between the equation, the graph, and the characteristic of the conic section. Conic section here is a hyperbola. Right, let's look at this example. Well, we have this. We have to do the completion square first. By the way, we have the y square first and then x square. So let's just put the y square first and then the x square. Y square, 9y square plus 54y, and then the x minus x square plus 4x. Let's move the 68 to the other side. That makes it -68. Right, next, to do the completion square, before we do that, let's just factor out the 9. And that gives us 6. y, and factor out the minus x squared minus 4x still equal to negative 68. Right, now we still do the completed square. We're going to add something here to make it a perfect square trinomial. And we're going to add something here equal to negative 68. Right, we're going to add something and add something. Well, I hope I don't have to use that much of it. Right, now what we'll do is take half of this number, that's plus 3, and then we square it. That will be 9. Half of this number, and then square it. That will be 4. Right, so what did we do? We're going to add 9 inside, but this 9 times this 9 is 81, so instead we add 81, not any 9, and then we add 4 here, but that with the minus, so that minus 4 on the other side. Now put all of that together, we will have y plus 3 squared minus x minus 2 squared equal to 81 minus 68 minus 4. 81 minus 68 minus 4. It's going to be 9. Don't forget there's still 9 here. Right, and then to get 1 on the right hand side, divide everything by 9. We have y plus 3 square over 3 square minus x minus 2 square over, sorry, 3 cancel out, so this is 1 square, not 3, and so this is 3 square equal to 1. Right, so from this equation we can get the centers 2 on the x-axis and negative 3 on the y-axis. So the center would be x equal to 2, h and k is 2 for the x component, and y plus 3, so y minus negative 3. So the center x equal to 2, y equal to negative 3. This is the center. Right. Next, we draw the box 1 below the y, so 1 up, 1 down. And then 3 left, 3 right. 1, 2, 3. So we draw the box. Right, 1 up, 1 down, 3 left, 3 right, and we have the box. It's easy to graph. They're popular than to come up with the equation, which is not that bad either. Now we lead with the y, so the vertices will be up and down from the center, and that distance is going to be 1. So we have the distance from the center to a vertex is going to be 1, and that is going to be a. And the other distance is going to be b, which is 3 left, 3 right, so b is 3. Right, we have a and b. Of course, we can find c. So c square is 1 square plus 3 square. So c square is equal to 10, and c is equal to square root of 10, which is 3.16. So meaning that the center we go, by the way, two vertices and the center line up vertically. So we have the transverse axis is vertical transverse axis, and the ellipse, the parabola is going to be vertical. Right? Now, if we have to write the coordinate of everything, we know the center is 2 and negative 3. If we want to go to the vertices, we start from the center. But the vertices is 1 unit up and down, so we're just going to plus 1 or minus 1, and that gives us the coordinate of the vertices. The foci, we still start from the center. And the foci 3.16 up and down, so that's just plus or minus square root of 10, that is c. That gives us the foci. So here and here. And then the asymptotes will be y minus negative 3 or y plus 3 equal to plus or minus the slope up 1 unit, right 3 unit, and we have x minus 2. Right. Yeah. So just like that. So we have to get to the center first, 2 and negative 3. Do the completion square from that. And then when we have the equation, the y under the y, so 1 left, 1 up, 1 down, the 3 under the x, 3 left, 3 right, draw a box. We start with y square, so this is going to be vertical, hyperbola. And then the distance from the center to the vertex, that is 1. The distance from the center to the other, to have the box, is 3. So A and B give us C, which is the distance from the center to a foci, to a focus. And then we have 2 foci. And everything will spin off the center. The vertices, 1 up, 1 down, the foci, plus or minus square root of 10 on the y component. And the asymptotes, that's what we have. Right. So as always, try to link between the equation, the graph, and the characteristic of it together. And once again, the characteristic of a parabola center in the middle, next to vertices, and then 2 foci. Draw the box first, draw the diagonal, and then determine if it is vertical or horizontal. The graph will go through the vertex and approach the asymptotes. So that's what we have. Right. Next, let's look at this application. Suppose that 2 people standing 2 miles apart. So A and B, 2 miles apart. 1 mile is 80 feet. So that's about 10,560 feet apart. After a period of time away, both see a flash of lightning. So the speed of light is 300,000 kilometers per second. So that is extremely fast, almost, let's just consider instantly, compared to the speed of sound, which is a lot slower. Right. So after a period of time, the person standing at the point A hears the thunder, and 1 second later, the person standing at B hears the thunder. Of course, B is further away from the lightning strike, so that person will hear the lightning, hear the thunder a little bit behind the person standing at A. Alright, and we know that it's exactly 1 second later, so that is very important. The person standing at point B hear the thunder. Right, if the person standing at B is due west of A, so that's what we have here, and the lightning is striking at the point that is not A, so lightning strike at that point. Where did the lightning strike occur? So we should find the x coordinate and the y coordinate for that. By the way, this is the very useful application. Now we only have 2 points. If we, of course, we have 2 points, and we know the distance between them, we should be able to determine that the path of the lightning must be on the hyperbola, because we know that the difference between the distance is going to be equal to 1 second that sound travel. So 1 second, the sound travel is 1100 feet per second. So 1 second it will travel 1100 feet. So we know the difference between that lightning strike to B, subtract the lightning strike to A, that those subtract equal to 1100 feet. So with that, because they have the constant, the difference between the distances are constant, so we know it is hyperbola. So it is useful in real life. What we have is the GPS. The way it works is they use 4 satellite, and they just take the difference between the GPS is nothing like it's just a device. It will take the signal from 4 different satellites to locate where we are, and when it takes the distance, it actually did not get the distance. What it gets is the time from some certain satellite to that point, and we know the difference between those distance. The difference between the time that travel from certain satellite to that point, and we need 4 satellites to determine where we are, not only on the Earth. We need 4 satellites to determine where we are on the Earth, but not only that, if we travel on an airplane or we on the surface of the Earth, with 4 satellites we would be able to tell where we exactly are, not on the surface of the Earth, but also the altitude from the surface of the Earth as well. So we need 4 satellites for that. If we only have 3 satellites, we will not be able to determine, let's say, the altitude. We know on the surface of the Earth, but we don't know the altitude. We need 4 satellites to know where we are on the altitude as well. And the way it works, it's just like the 3-dimensional version of what we're doing here. Right, so now we know the distance between them, 10,560 feet. Now, because it is on the hyperbola, let's say the A and B, 2 full sides, and let's say if we have the point C is here, then we say the distance, I just say BC minus AC. By definition, that is constant. 1 second, the sound travel in 1 second is 1100 feet per second, so the difference will be 1100 feet between BC and CA. So that's good, that's good. Now, instead of point C, let's say this is point A here. It's on the transverse axis. We have BE subtract EA. What's that? By definition of hyperbola, the distance between them has to be constant. It's also 1100 as well, which is good. Right, any point on the hyperbola we have this characteristic. Now BE, if we have the centers here, we have BE, right? Now from C to vertex, it's going to be A, and from C to B, from center to the foci, to a focus, it's going to be C, little c. Right, so BE, if we're going to write the distance from B to E, it's going to be C and A. So C plus A is BE. And then E and A, well, that is the difference between the center to a focus minus the center to a vertex. So C minus A. So that those distances is equal to 1100. Right? So the big distance is C, a little distance is A. So here we have A plus C and C minus A. Alright, so subtract C plus A minus C negative. Negative is plus A. So what do we have? 2A is equal to 1100. So A is equal to half. Half of that will be 550. So distance A is 550. Actually, the scale here is way off. Should be very close here. Right. So that's why we have A is. Of course, C, the distance from the center to a focus, is 5,280. That easy from the graph. So we have C, we have A, should be able to find B easily. So A square plus B square equal to C square. So to get B square, C square minus A square. So what is B square? Right, C square 5280 square minus B minus A square, sorry. And we have that 27,575 and 900. Right, that is B square. And then we can get B, of course, square root of that. Right. Right. And the equation, this one is horizontal, so we have x squared. The center, let's say it's 0, 0. So we have x squared minus y squared equal to 1. And below the x, it's going to be left and right a unit. So it's going to be 550 squared. Below the y, we go up and down b unit. So it's going to be that number. So there we have the equation of the hyperbola. The rest is easy. We know the line strike is at this point it is directly above north of A. So we know that we have x is equal to 5280. Substitute in this equation, we solve for y. So we have 5280 square over 550 square minus y squared over 5251 square equal to 1. Of course, then we just need to solve for y, and we're going to take, of course, the y that is positive. So that's easy. I'm not going to solve for that, but that's the idea. So, of course, the GPS will work like this too, but it is a three-dimensional case. And with that, we can locate the point. Right, kind of like that. The difference is that in the GPS, we have one point, and we go, so the sound light is arcing light will broadcast the signal, and then so those are the sound lines. We need 4 sound lines to determine where we are on the Earth and the altitude as well. Right, so once again, they are 2 miles apart, so that is the distance. Cut that in half, give us the distance c from the center to a focus. Next, from the center to the vertex, we do the math and we figure that out. That is 550. Yeah, so a c plus an a minus a c minus an a. That's what we have. Right, and when we have a and c, we should be able to find b. Come up with the equation. Known x, we can find y. Right. So that's what we have for hyperbola. Once again, the characteristic of hyperbola: center in the middle, 2 vertices, and then 2 foci outside the box. The box will be a from the center to a vertex, and then b, a, b, c related by Pythagorean theorem, where c is the biggest one from the center to a foci, to a focus. Right, and then the equation. Right, so I stop section 9.4 here. As always, thank you for watching, and see you in another video in Precalculus.